In a universe with trillions of stars, billions of Earth-like planets, and nearly 14 billion years of history, we should not be alone. Statistically, life should have emerged many times. Intelligence should have evolved somewhere else. And yet, there is no sign of them, no signals, no probes, no megastructures, no evidence. In 1950, physicist Enrico Fermi asked a simple question during lunch with colleagues: where is everybody? That question still echoes today. This is the Fermi Paradox. To understand the paradox, we must understand scale, the scale of the galaxy. Milky Way contains between 100 and 400 billion stars. Modern astronomy has revealed that most stars host planets. We now know planets are not rare. They are the rule. Thousands of exoplanets have been confirmed. Many lie within their star's habitable zone. Statistically, billions of potentially habitable planets exist in our galaxy alone. And there are trillions of galaxies. So, life should not be extraordinary. It should be common. The Drake equation. In 1961, astronomer Frank Drake formalized the discussion into a framework known as the Drake equation. It estimates the number of detectable civilizations in the Milky Way. The equation includes rate of star formation, fraction of stars with planets, number of habitable planets per system, fraction where life emerges, fraction where intelligence develops, fraction that create detectable technology, and the lifespan of such civilizations. We now have better estimates for the early astronomical factors, but biology and sociology remain uncertain still. Even conservative inputs often produce non-zero results, meaning there should be someone out there. Now we reach the strongest scientific tension. Even without faster-than-light travel, a civilization capable of interstellar expansion could colonize the entire Milky Way within 10 to 100 million years. That sounds long, but the galaxy is over 13 billion years old. If even one civilization began expanding a billion years ago, we should see evidence everywhere. Civilizations could build Dyson spheres, megastructures, energy-harvesting shells around stars. Yet we observe none. The galaxy looks natural, untouched. This is the heart of the paradox. Given time and probability, why is the sky so quiet? One explanation is known as the Great Filter, somewhere between lifeless matter and galaxy-spanning civilization. There is an almost impossible step. It could be the origin of life, the jump to complex cells, the emergence of intelligence, the survival of technology. If the filter is behind us, we are extraordinarily lucky. If it is ahead of us, then civilizations destroy themselves before spreading. Nuclear war, runaway artificial intelligence, ecological collapse, biological catastrophe. The silence of the cosmos could be the graveyard of failed civilizations. This is where science becomes existential, because if the filter is in our future, we are approaching it. The paradox does not prove extinction. Other scientific explanations exist. Abiogenesis may be nearly impossible. It took Earth hundreds of millions of years just to produce simple life. Complex life took billions more. Intelligence appeared only once. Perhaps the chain of events required is so fragile that it almost never repeats. Technological societies may last only a few thousand years. If their detectable window is brief, overlap between civilizations becomes unlikely. We may simply be alone in time. Search programs like SETI have only scanned a tiny portion of the sky and radio spectrum. The universe is vast. Our search has barely begun. Silence does not equal absence. It may equal immaturity. Advanced civilizations might turn inward, enter virtual realities, abandon expansion, avoid broadcasting, or perhaps they hide. The so-called dark forest hypothesis suggests that in a dangerous universe, survival means staying silent. This idea is speculative, but it highlights a sobering possibility. Silence may be intentional. The Fermi Paradox is not merely about aliens. It is about our trajectory. Are we rare? Are we early? Or are we doomed to follow a path others already have? Then our survival matters cosmically. If civilizations collapse, then we are witnessing a universal pattern. Or we may be the first technological species in a young galaxy, the first to look up and ask the question. If that is true, then the future of intelligence depends on us. The night sky appears empty, but it may not be empty, it may be quiet. And silence has many explanations, some hopeful, some terrifying. The question remains the same as it was in 1950. Where is everybody? And perhaps the more unsettling question is, what will they one day ask about us?